In a world of gigabit fiber and NVMe storage, the bottleneck of your internet experience isn't your physical line, it's the protocol. Standard browsers utilize a single serial stream for data retrieval, leaving them at the mercy of TCP's congestion window and the high-latency tax of global routing. This is where Internet Download Manager changes the game. The story of high-speed data retrieval on Windows began in 1998. Tonek Inc., established by a group of computer scientists, recognized that the native networking stacks in Windows were never optimized for massive high-concurrency data acquisition. Since the release of version 2.8 in June 2001, IDM has been a relentless evolution of C++ engineering, transitioning from legacy transport driver interface filters to the modern Windows filtering platform. The engine's primary differentiator is smart dynamic file segmentation. While most competitors use static segmentation, dividing a file into fixed chunks before the transfer begins, IDM employs the in-half division rule. During the download, the engine continuously monitors every active stream. When a connection completes its assigned segment, it doesn't go idle. It immediately identifies the largest currently active segment and splits it in half, taking over the second portion. This ensures 100% saturation of your available bandwidth until the very last byte is retrieved. Beyond segmentation, IDM optimizes the network transport layer. Every new connection requires a handshake tax, a series of round trips to establish TCP and TLS security parameters that can consume up to 40% of a server CPU capacity during peak traffic. IDM minimizes this overhead through full connection reuse. By keeping the underlying socket warm and reusing authenticated pipes, IDM reassigns connections to new segments almost instantaneously, stripping away the latency of traditional web requests. This is particularly effective with TLS 1.3, allowing for zero round-trip time resumption. IDM's advanced browser integration isn't just a simple extension trick. It's powered by kernel mode drivers like IDMWFP.sys. By leveraging the Windows Filtering Platform, or WFP, IDM operates at a lower level than the browser itself. WFP shims intercept network traffic at the transport and network layers. When a matching HTTP request is detected, the system invokes an IDM callout, allowing the manager to take over the stream even if the browser's extension is disabled or limited by OS security policies. As the web moves away from TCP toward UDP-based protocols, IDM has adapted. Standard TCP suffers from head-of-line blocking. If one packet is lost, all streams on that connection must wait for a retransmission. IDM's engine now supports HTTP3 and QUIC, which currently power over 34% of the top 10 million websites. By leveraging QUIC, IDM benefits from independent data streams, making your downloads resilient to packet loss and allowing for connection migration, which keeps your download alive even if you switch from Wi-Fi to mobile data midstream. The final battle is fought on your disk during the assembly phase. After retrieving all individual segments, IDM must merge those dozens of temporary files into one. On a traditional HDD, this creates a massive I/O bottleneck due to mechanical seek times, while users are advised to keep temporary and final directories on the same physical drive for simple metadata moves. Modern NVMe SSDs, reaching speeds of 7,000 megabytes per second, have turned this once multi-minute wait into a process that happens in seconds. Even browser integration has become a technical battlefield. Google's shift to Manifest v3 has limited how extensions can interact with network requests. IDM circumvents these limitations through its native messaging host, creating a secure direct pipe between the browser and the main idman.exe process. This ensures that session cookies and authentication headers are passed seamlessly to the download engine, even under strict modern security frameworks. However, high-speed downloading often triggers false positives in security software. Errors like SSL Connect Error 5 are usually caused by antivirus SSL inspection mixing up encrypted data buffers. IDM's engine handles this through data integrity fallback. If a segment mismatch is detected, IDM will automatically fall back a few bytes and re-verify the data to ensure the final asset is not corrupted. In competitive benchmarks, while free alternatives like Free Download Manager offer BitTorrent support, IDM remains the industry leader in raw HTTP and HTTPS throughput. Its more aggressive dynamic segmentation and highly optimized C++ core provide a measurable advantage in high-latency environments. Internet Download Manager is more than just a utility. It is a sophisticated networking stack designed to bridge the gap between your physical hardware and the inefficiencies of the modern web. By combining kernel-level filtering, dynamic rebalancing, and protocol-aware connection pooling, it ensures that your system is never the bottleneck in a world of infinite data. For the technical professional, it remains the gold standard for data retrieval.